I'm talking about practical Haskell web apps tonight. I thought I'd sort of set some expectations. You know, this is not going to be timeless truths about functional programming. When architect critics get together, they talk about form and structure and meaning. When artists get together, they talk about where you can buy cheap terms. And this is a cheap terms talk. This is what the Haskell web app framework situation looks like at the moment. It's kind of a mess sometimes, but you know, I can hopefully guide you through it a little bit. So, first off, why should you give a damn in the first place? You know, we've all got heaps of web frameworks we're used to, we don't have to convince our bosses to use, blah, 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 blah. I've been running Haskell web apps for about 5 years now, and I like it. It's a lot of fun. Partly the binaries themselves are fast in general, so long as you don't do anything really stupid, because the compiler's pretty good, and you've got cheap threads. They're fast to write, which is something that people don't seem to take into account very often. That if you're writing a Rails app, sure, you know, you bang out sort of generators left, right, and center, something fails, and oh shit, what happens now? You know, you spend a lot more time debugging than you do actually writing new code. I spend most of my time in Haskell writing new code and refactoring when it starts to look grotty. And refactoring with heaps of types is really easy and kind of fun. It sort of satisfies that kind of mindless screw sorting part of your brain that you know, likes things to be ordered. As a deployment thing, in general, most of these apps compile everything into a single binary, and with a little bit of work, you can kind of package in your templates, your HTML, JavaScript, everything. It's just all in one big binary, which means you don't need any particularly complicated Nginx, Apache setup, anything like that. It's just a binary you deploy somewhere and run on a port. So this means you can, a lot of the time, have basically caveman deployment methods. It's just like you async a binary to a directory. There's another thing called Keter that comes from the USERT project that will pick it up, check it for some basic well-formedness, and if it's good, kind of seamlessly swap your new incoming connections. And it's fun. However, you know, while it's still quite a small ecosystem, there's way more fragmentation than anyone would expect. And this is, I mean, it's kind of the Lisp curse. You know, it's easy enough to write a small web framework that everybody kind of wants to have a go. So there's a lot of them out there. I won't be talking about it. So here's where the problem starts. Your typical Haskell library, because it's easy to export, a lot of libraries, they'll be like maybe one function, you know, or just a very small set of functions and a couple of data types that very precisely do one thing. And this is very satisfying to a certain kind of line. You know, you look at auto-parsing. It's a really fast parser, very, very precise semantics. Conduit, you know, you can handle streaming data in a way that means that everything gets cleaned up nicely and it's pretty fast churning things through, and it just kind of works. You know, async is a really, really nice way of managing asynchronous processes using Haskell's runtime system. You know, you've got this idea of a sharp knife, do one thing extremely well. Web apps aren't. You know, I don't need to tell you that. There's just a heap of stuff that needs to be done. Even if you had like one sharp thing that did everything well, you would still spend an enormous amount of time kind of gluing them all together in a way that makes sense for the way you want to set stuff up. If you came along to somebody's project who set all of this stuff up this way, you're still going to have to spend a lot of time working out, you know, how it works. You know, your routing, HTTP methods, database integration, migrations, all that stuff. You know. So that's why sometimes the Haskell, that's why you get these new frameworks coming along, because it's like, oh, surely I can do this better, and they build something that works in there, and it doesn't work.
Is that just the way it is, or is there a reason why it is that way? And I'm asking because I don't really know anything about this.
I think part of it's the mindset of most Haskell devs end up using Haskell. I mean, it's almost nobody's first language, right? You end up there because you're sort of on a quest to find something more precise, more correct. So, of course, they're the people who are least likely to be satisfied with you know, a big hodgepodge melting pot thing. You know, which is a pity because I think in this case a big hodgepodge melting pot thing is sort of the right answer, not to give away the rest of my talk. So, speaking of the big hodgepodge melting pot sort of thing, Rails was my first kind of commercial environment, and there's a lot wrong with it. You know, I probably ran for a long time about performance in Rails. The thing is, it kind of works, and you know, if you're not doing anything weird, you can just accept the golden defaults. Don't touch them. You don't care about them. It works. Just go on to the next bit. Well, let's just say, I guess. So, finally, getting the ecosystem, the actual way it's sort of set up. These, I think, are the most popular kind of frameworks. There's other weird ones like MFlow and Haskell, but I don't really know anyone using them, but they're authors, so I'm just leave it alone. So Snap, the sort of single page, the very minimal web apps like Scotty and Spock, Y, which is the very, very low level one. Servant, which I love. Oh my god, it's beautiful. Very high level, very type driven. I'll talk about that a bit later. And Yasode, which is kind of the 1,000-pound gorilla in the room.
I'm sorry, are those you're talking about, are they the Swiss Army knife model of web servers, or are they?
No, they're more componentized, except Yasode, which is the one I'll spend most of my time talking about.
Okay, thank you.
So Snap, I'm going to skip over really quickly because I've never built anything non-trivial in it. You just need to build it. Just a very component-based. The idea is you can pull in a bunch of different components and combine them. I'm going to show you working practice. Sorry, I can't be more helpful there. So this is Scotty. Spock is basically exactly the same. It's the narcissism of small differences, if I'm going to be honest. But the idea, if you've used, say, Sinatra or Flask in Python, you've got this model where you've got some monadic thing where it's like, okay, we're going to set up Scotty on port 3000, and here's, one of my handlers, and it'll generally be, get sets up a get handler at that URL. Post will set up a post handler at that URL. You grab your params, you grab your post params, you print something back. So it does have this nice effect that all of the roots of your app are really obvious. Problem is, of course, once you go big app, enormous file, you end up modularizing it yourself anyway, and it provides absolutely no support for all of the basic stuff you need to do: authentication, database integration. You're going to roll these yourself if you go this model. It's perfectly fine for a little demo app to chuck up something.
Would this work okay for like an internal microservice? We don't worry about authentication with just internal.
If you don't care about authentication and you don't care about having a database and you don't care, if it's really that simple, then honestly do it whatever the hell you like. It just doesn't. If there's no say, who cares? This is a recent joke. Y is what? It's like the rack. If you've seen Ruby, very, very low level, you get just a request, which is the underscore here, which I'm completely ignoring and returning hello world. Don't do this. The people use this to cheat benchmarks, and that's like the only thing. Okay, something I actually want to talk about. Servant is, oh my god, I love Servant so much. It is so pretty. So to explain this type here is my whole API. It's a type of my API. So I'm saying, all right, at /users, then /users, there's a GET request, and I can render, this is a type list, so quote, bracket, square brackets, and then I can have a list of kind of content types that I can render. So that can be JSON, any kind of, if I've got different kinds of HTML templating, things I'm willing to provide, I can provide that there. And this is the type of the thing I'm going to render. So you set this up and then, say, okay, give it a go and say, oh, well, you need to give me an instance for this particular thing to show, so I know how to show a user in JSON form. So I've got this really nice sort of to-do list kind of idea of how you do development. You set up what you want, and then the type system will tell you, okay, cool, but I need to know how to render this thing. So you just just almost mechanically go through, fill in the instances for each type class, and you're done. So this is, it seems like a lot of work for not that much, except when we get to here. So I mean, this is just normal state saying serve. We've got a little type parameter here to say this is the thing that we're serving. I'm not entirely sure on the reasons for that. I don't need to dig into that further. But the cool bit is that I now have this function in CJS or something, some JavaScript code. Just from this type, I can generate client functions. So you don't ever write any client functions for connecting to the website. They just get generated for you from the definition of the type. I fell in love with this when I heard about it. It was just magic. And of course, that's a bug. Slightly lower res. Never mind. So the problem here is that the guys behind Servant are really working hard to make it kind of the perfect web framework, which means if they decided they did something slightly wrong a couple of iterations ago, even if it's like, actually I think those functions should be in this different module, they won't so much deprecate the existing one and just import it from the old one, so you've got time to move, they'll just change it. So the attitude of backwards compatibility is kind of horrible. It's kind of based, authentication still getting sorted out because, if you've got authentication, then that's got to, because you've got to generate it all from the type, the client stuff as well, the authentication's got to be baked into that type as well. So it gets a lot more complicated in that sense than, your standard method of doing this stuff. And then there's just, I've done like 3 or 4 websites in Servant, and almost always I end up moving over to Servant because of some dumb thing like authentication, or I can't set a cookie, set something in the session. Just like basic stuff that you need to do in web apps all the time, and you'll just run into it. It's like, crap, all right, something else. So here's what I actually want to talk about. This is my workhorse. This is what I use all the time. This is the most sort of Rails-ish of the web app frameworks I've used. It's a Hebrew word, yesod. It means foundation. You can swap bits in and out, but there's definitely kind of a golden path. Way that this has all been tested together, it all works. You're going to have minimal problems. It's feature complete in a way that Servant isn't. I haven't.
What complete?
Feature complete. I've got I think 1 or 2 commits into yesod, and really small things like one into yesod test and some small thing into the framework itself. But I've used it really heavily, and it's very rare that you hit anything that you need in this command. It's mostly type safe, not to the level of Servant. Doesn't have that kind of idea of, well, here's an API and generate stuff like that, but it's pretty close. And all this stuff like you expect, things like support for an environment that you don't have to load yourself, database integration, whether it's Postgres or SQLite or MySQL if you're feeling Massachusetts. It's just kind of all there. So
when you said back to Servant, when it generates a client code, that's all in Haskell.
Yeah.
Right. Okay. So
yeah. So yeah, you need to use something like CJS. There's also a PureScript model for that. If you're into that, I haven't tested. I've used CJS on introduction. I haven't done more than poke the PureScript one.
okay.
I think there may be some support through Swagger for creating JavaScript client APIs as well, but I haven't played that at all. Okay. Okay. So before I get into what it actually looks like when you run one of these apps, I want to talk about one of the weirder parts of yesod, which isn't super common. A lot of your app actually gets constructed from code at compile time. So you're writing code to write code for they're very easy. The thing is, you've got these two models, template Haskell and quasi-coding. And the thing is, template Haskell looks a lot like you're just manipulating the abstract syntax tree. You're building it yourself, and honestly, most of the time, it's pretty verbose. It's a pain in the ass to do. As you understand it in detail, it's just code that writes code. So this is what you actually write. And this is much more of a declarative syntax. And effectively what it is a parser just gets past this chunk of text. Parses it, treats something like a hash slightly differently, you get interpolations kind of thing. And it looks like, YAML config or whatever, except it's type checked at compile time. So you catch a lot of these errors way earlier. So this, that was actually a root file. So you get give you migrations. That experience that I talked about in Servant of, saying, okay, now I want to serve this thing, and then getting the to-do list of, okay, in an instance of this data type, so I know how to store it to the database, I know how to render it into JSON, I know how to put it on a web page. All of these things, it's very much type class based, and kind of interface. It gives you a type safe link construction, templates, config. You can't actually have wrong config without really working hard. The compiler will actually check it for you. So yeah, do it at compile time, don't get page. Any questions?
What if don't get page
We're in pager. Don't have your website fall over at 3 in the morning your time. So looking at this is what the database description looks like. This is an embedded DSL from Persistent. And this is telling me that my data type is user. It's going to go into a SQL table called users, and here are the kind of fields that are in each of them. There's a couple of kind of special things here, like UUID. There's a special UUID SQL type. That's what we want to map it to. The default's going to be this thing because we don't want to create it ourselves. We're going to have a unique constraint. So what this does is actually creates SQL DDL and runs that. And it also creates a data type for you in Haskell. So this means that basically the code dictates what's in the database, and there's no way for them to get out of sync. Which is it's a really, I think it's wrong for us for it. It's a really nice property to have.
So what is persist lowercase on that syntax? Is that the name of the function it generates? Or?
This is the quasi-quota that you're calling, and it provides, I think, persist upper and persist lower, and they're just different defaults for the way it names things.
Oh, persist lowercase is like a function that a quasi-quote function you're calling?
Yes.
This
is the function I'm calling. This is the quasi-quota syntax. This is the argument I'm giving the quasi-quota.
Okay, I follow that.
Yeah, right. So yeah, you call that with this, and then hopefully whatever that creates is type safe, and if it's not, it'll give you a complaint.
What is quasi-quota? Remember something?
It's a bit, well, that's what I was talking about with template Haskell. They're kind of the same thing, but with template Haskell, this is the difference here. This is quasi-quota. This is template Haskell. So with template Haskell, you're creating the abstract syntax tree. With quasi-quota, you're handing a chunk of text, this is special stuff that I don't want to get into, to a parser. The parser will give you back to the code, and then try to compile. So this is kind of, it's a user interface for the devs.
And I would guess quasi-quota probably comes from like list. You quote things in list. That's probably really what the name from.
Yeah, pretty much. There's a Haskell paper called "Why It's Nice to Be Quoted," which I think the Shields. I think I can't remember, but yeah, all the details in that.
Yeah. I'm curious, how would you even know looking at that code that the top is template Haskell code? Because it kind of looks like a first glance any other Haskell.
Oh, okay. So this, that's actually a good point. This isn't technically, it's code that creates template Haskell data types. What you would actually do is call curryM in a splice context with some argument, curryM7. So I think it's $curryM7 close bracket, and then it will create that code and put it at the top level.
Oh, so this is like a function that you would use in your template Haskell code?
Yeah, but they're not precisely the same thing. I was still writing slides about half an hour ago, so yeah, not precisely the same.
Would it,
Good.
would it be incorrect to think that it's like a DSL, basically?
Oh, it's absolutely DSL. And one of the great things about quasi-quoting is that it gives you the ability to write any DSL you want. So I'll talk about it a bit more, but one of the quasi-quoters I really like, it's just really simple, dumb stuff, like ASON QQ lets you quasi-quote like literal JSON values, but it'll type check it at compile time to check that it is actually a valid JSON string. So, that's really useful for like tests and these kind of things. You just sort of set them up. It's like, well, I know it's kind of the right format. If I actually want a wrong format to check that I do the right thing, I have to do a string. But if I don't want to fiddle with that one, that kind of thing. So, database view as well. We've got, this is the same example I had before, but this is just saying at users, we're going to call the user, the get users are if it's a get request, or post users are. Now this isn't Haskell syntax at all. This is completely arbitrary syntax that the Sovens sort of come up with, but it reads reasonably nicely. This also creates a link for this thing, and it's less interesting. Well, so the users are link has 0 arguments because we don't have any hash arguments in this thing, and that means I can create a link to that if, a month down the track we decide it should actually be people rather than users. I don't have to go and fix all my links anymore everywhere. Because I've used the users are link, and that kind of that will always work if it compiles. Does that make sense? No breaking links. It's really nice. All quasi-quoters. So this is our template DSL. So same as Hammel or anything. Type checks, you've got interpolation, you can check the page title is in fact something that can be interpolated, the style sheet, this is a link syntax, and this sort of dollar syntax here is kind of your splicing in method. I think it's a split on this stuff. Like, I know it's really nice to be able to pass a template to your designer and say, here, go to town, use HTML or Hammel or whatever. But this does make it type safe. It depends on your situation, I guess.
So there isn't a way to use another template language?
There is.
Okay.
Yeah. But yeah, they've got fairly strong golden defaults, but you can splice in whatever you want.
One of the banes of DSL.
Sorry, could you speak up?
Oh, sorry. One of the banes of disadvantages of DSLs is when you put something wrong. Okay? If you made a mistake, typing this in, then an eruption of errors, and it's very hard to say.
It can happen.
You're 7.
It can happen. The implementation of quasi-quotation is fairly careful to have links back to the line number at which it was generated rather than the line number of the generated code.
Right.
So, you can usually track it back to class. Sometimes, it'll just be, hey, there's a problem at the first line of this quasi-quoted thing. It happens
somewhere in the code.
Right. Usually I try to make, the only time I've really had a problem with that, the template stuff's really good about it, like the HTML template stuff. For some reason, the database template stuff is less so. So usually I just have a known good state, make a change, oops, I screwed it up, roll back, and sure, that's usually how I get around that. So, and you've got a similar thing for CSS and JavaScript, which I know it's a very old model of sort of delivering JavaScript, but actually kind of pasting template stuff into it and then serving it. But I haven't actually used that, to be honest. I know it works the same way, but I would almost always just serve JavaScript that talks to JSON APIs. Okay, so we saw the table layout DSL. From the system, which is the database layer. The standard config of your SOAP will set up, whether you're using Postgres, MySQL, SQLite, whatever. It will set up the config for test and dev and all this kind of stuff. And it's also got this kind of primitive query language. Less than SQL, you can get a list with some kind of condition on it, and you can get an ID. You don't really want to do joins or subqueries or anything fancy there. That's what Haskell goes for, which operates on the same data types and is mostly type safe. And you can save kind of pieces of queries and recombine them in different ways, which is what I always missed from SQL. So, like I was saying, a lot of this stuff is driven by type classes. From JSON to JSON, really standard ASON kind of type classes, everyone uses them, and then path piece and system stuff. Hopefully you can read that. Just a way, if something implements to JSON, you can turn that A into a value, and a value is just a JSON value. From JSON lets you give it a value, which is a JavaScript object, and may or may not be able to parse it into something useful. And if you can't parse it into something useful, it'll tell you why it failed. Path piece is just a read type class that's not terrible. The standard read type class is kind of awful because the standard way of using it is really partial. It's read string to A, which means that if it can't parse it to an A, it just crashes your program, which, it sucks. And then this is how it parses a URL into a root. So it'll split it up on the slashes and check that each component of it matches something you expect. So if we go back to this thing here, if we again post, we've got blog / foobar, and blog ID is actually numeric or prime numeric, whatever the kind of instance of path piece is there, it'll say it'll give you 404 because there's no way you can access that thing. And persistence are the final piece there that lets you map things to the database and back. Mostly you don't even ever need to write this stuff. It's only when you've got like special purpose data types that aren't already accounted for. So I figured after all of that, I should show you what an actual handler kind of looks like. So for the handler of typed content, this is going to require manager is going to go into the database. If it can't find a manager, i.e. you're not logged in as a manager, that will chuck a 403 or 401. I can't remember, but it'll kick you out at some other point. Once you get to this point, it will say, all right, you can select rep one of these two things, and it will provide rep a JSON instance, provide rep a HTML image. WHAML is the template thing I was talking about before. If you ask for XML, you'll get it, can't handle that method. And it'll only do kind of one of these because Haskell is lazy, it's just a thumb until you actually ask for the thing.
So if the require manager returns correctly, it returns a triple, which you parse into something in a company.
Right, so this is something from my work code base. I just pulled it as an example. It's not hard, so it's just what.
Okay, I just wasn't sure.
That's just true syntax. Okay, so what sucks about this though, migrations aren't ratified. So basically you can run, or you can ask it to tell me run the migrations that have to be run, or tell me what migrations need to be run. And that sounds great, except that almost all the time when you run migrations, you also want to say, okay, and the default value is going to be this for these new ones coming in right now. Or you can compute the new values in this new field by running this code from here. Derive it from something. It makes it really hard to do that. So after struggling with this for a while, I ended up just getting it doing two things. Setting up Rails active record migrations with SQL and running whatever I needed to. And I had a test step that would break the build if there were any outstanding migrations to be run. So that was more or less just a test that wouldn't let you deploy or even merge until you're in sync.
So you use actual active record migrations?
Yeah.
Okay.
But, I think there are some solutions in Haskell, but you know, I knew the active record one worked, and it wasn't clear that the other ones would give me anything above that. I've already got all the type safety. It's really just about spitting out the SQL and running it at the right times. All of this quasi-coding stuff, the template Haskell, it does mean when you change files that have template Haskell stuff in it, the compile cycle is a bit slow. It's kind of a pain in the ass, but it's what it is. It's what I want when you computer for.
Does it memoize anything, so it doesn't check C?
I don't think it, not below the level of modules.
Okay.
So if you change that module, yeah, it recompiles everything in there. It got a lot faster in the recent release of the compiler, which had been sharing. Yeah, it's still a bit slow. You know, you get around that by trying to keep each quasi-coded thing in a separate file, so you're not, you know, if you had like quasi-coded.hs, it's all your quasi-coded stuff, you're just going to sit it forever. I wanted to do that like Slack-esque thing, and you know, food.slackhq.com on my last thing. That turned out to be quite a pain in the ass to do. I ended up having to write a middleware that mapped the first element of that domain to the first path thing, and just pretending that's what it always was. Yeah, it's really nice. Finally, it's not. I was talking about the templated JavaScript stuff before. It's a really old model. Most people I know doing single-page apps are talking to it from, you know, a JavaScript app, and there isn't anything built in to let you do that to generate GHCJS. Probably the right thing. GHCJS is still kind of a pain in the ass to run, and it doesn't make any slower to build, but it would be nice to have. So, what's cool? Most stuff is there and it works. Raise an issue on the issue tracker and stuff gets fixed really quickly. There is a story for integration testing and stringing stuff, and yeah, basically it's just all there and it's fun to use. Yeah, I think that's it.
So what does it look like in terms of application servers and also deploying them?
It's up to you to a certain extent. There are a couple of different ways you can run it. The way I usually run it is there's another app called Kita, and that's something that watches a directory. There's a special format for a Kita ball, Kita tarball, that's included with your code. So you know, you run make Kita and creates a thing, you sync it into the special little directory. When you're finished, it notices it's there, moves away, checks that it's running, and you know that it's registered for a certain domain, and then kind of all new things go to that, and it kills the old one when all of the requests does not go into that.
And does it allow you to run multiple instances, or?
Multiple instances, in what sense?
Of the applications. Like if you have like Puma or Unicorn in the Rails mode, you're often running multiple instances.
You can, yeah, you can have them running multiple processes. You usually don't. It's easier to give the GHC runtime kind of just end cause and keep doing that, but you certainly can.
Okay.
And you know, if you want to run the same code on different domains, but different database options or whatever, you know, you can do that too.
So is your code kind of monolithic, or is it like, I would say I wanted to add a law, and I don't have a law in, you know, what I've got, so right, then I have to like pull it. Is there like a way to pull in a module and get the old off? Or?
Yeah, absolutely. It is actually called Yasod auth and Yasod auth, but you know, there is a clear API for doing that, and you can say, hey, use my module instead. But it's monolithic in the sense that there's a bunch of defaults that are just there and will generally work, but if you want to do anything in particular, you can make it dance.
Gotcha.
Any more questions?
Do they,
Sorry.
do they arrange it so that it's like Rails where they kind of want your restructure your project in a certain way, or is it just kind
A
of?
little bit. It doesn't have the same auto kind of, oh, I expect it to be here, and if it's not, I'm going to chuck a fit.
Yeah.
But by default, yeah, your handlers will be in the handlers directory, your models, usually in one big file because there's one quasi-coded thing. The model I usually do is I will actually have a separate separate library for anything that doesn't have anything to do with databases or web stuff. And I'll just, that's nice and easy to test, and I can have it as a separate thing, and I'll just call it in as a library. But yeah, you can totally have other stuff that's just in there.
What do you think is the best way of learning? I mean, I started looking through the book, but you also, get anything.
Look, I don't know. I think the book's pretty good, but ever since some learners told me that learning your Haskell wasn't at all useful to them, and I've been recommending it for years, I'm a little bit shy of saying what works for people who don't know it already. At least now I know what I don't know. I would recommend. Michael Stoyman gave a bunch of talks. Gave a couple of talks at LambdaConf this year, I think, and they're up on the site, and they talk about the JSON aspect of USOD in a bit more detail and the streaming aspect, which I just barely glanced on. Yeah, I can do that.
By the way, the slides, as always, I'm sharing the same GitHub repo, and I will write a comment in the GitHub event page, as always.
Yeah.
So please commit the slides.
Oh,
Yes,
when,
yes.
when I said link, though, I meant to.
Yeah, I know what you mean. The other links. Yeah, I'll put them in.
Yeah, nice.
All right. Thank you.
Let's have a 5-10 minutes break, and then we go with the next talk.